All right. Good afternoon. I'm Alex Russell. I'm a software engineer at Google. Has this been a great event so far, or what? This has been. I'm visiting from San Francisco, and this event has been amazing. I/O was about a month ago now, and the polish on this has been just as great, if not slightly better. Don't tell the I/O folks. So I'm here today to talk to you about Google Chrome Frame, and we're going to talk about what Chrome Frame is, how it can help you, how it can help your users, and how it can help you build better experiences for your users, and how it works, sort of at a high level. If you've got questions about how it works, I know that I'm between you and lunch, so we can answer some of those questions at lunch in deep specifics. But generally speaking, let's just talk about the plugin. So Google Chrome Frame is a plugin. But what it does is it helps you build with all the amazing technologies that Ian outlined in the previous talk much sooner than you would be able to otherwise. So, for instance, the Html5 Canvas tag, Microsoft just announced last week that they're going to begin to support Canvas in IE 9, which is pretty great. I'm really excited that I'll be able to get to use Canvas and SVG in IE 9. However, most of the world isn't using IE 9 yet, and if the uptake rates on IE 7 and IE 8 are any indication, it's going to be a long time before IE 9 is prevalent enough that if you're beginning a new project, you can go to your customers and say, sure, we'll build that for you, and we're going to use these new technologies that bring web technology to the level of desktop applications without having to worry about sort of uneven support or costing extra money to go try to build a different version that works sometimes with VML and maybe deal with performance issues on slow JavaScript interpreters, things like that. So Google Chrome Frame is a transition strategy that lets you use HTML5 much sooner than you would have been able to otherwise. But the most important part of that is that it allows you to do that while not asking users to necessarily switch browsers. So a lot of organizations are trapped. A lot of organizations have made a large investment in Internet Explorer specific technology in some cases, or simply haven't upgraded all their applications yet to go ahead and deal with the challenges posed by moving from old ways of building apps to new apps. So Google Chrome Frame is a plugin for Internet Explorer that lets you transparently render web pages using Google Chrome's rendering engine, and both sides opt in. So the user opts in to Google Chrome Frame by installing it, and the web page opts in on a per page basis by adding a meta tag or a header to the document that tells Chrome Frame, hey, I want you to render this document instead of the built-in rendering engine inside of Internet Explorer. So the important part about that last bit is that it means that web pages that depend on old technology, that depend on ActiveX, for instance, continue to work. Those pages won't have added this meta tag or this header. Therefore, the IE version that your users are still maybe tied to for business applications can continue to work the way they always have. Organizations don't have to go either adopt two browsers at once, one browser for one application and then one browser for other applications, which, in many ways is confusing to a lot of end users. They don't have to try to juggle that transition. And at the same time, they don't have to go make an all or nothing investment in a brand new browser. They don't have to go and do a forced march from all of their old applications to new applications that are going to work with modern browsers all at once. They can phase that over time, which is sort of the natural way to do it. If you would imagine a very large organization, it's likely going to be the case that if they've got 100 internal applications, one of them is going to lag. So if you're going to delay your switch to a new browser based on every single one of your applications supporting new standards, it may be a while. So you need a transition strategy. So before I tell you about how it works and how to use it, let me quickly show you what it does. So this presentation is rendering using HTML5 and CSS3 inside of Internet Explorer. So this is IE 8. You may know it, you may love it, you may not love it, but this is IE 8. So if I go to a web page that doesn't know anything about Chrome Frame. For instance, Google.com doesn't yet know anything about Chrome Frame. What we'll see here is that this is the regular rendering that I would expect. And if I right-click, I get the regular menu that I get out of Internet Explorer. However, if I come back to my DevFest slides, this is a different menu. This is the Chrome Frame menu, but the GUI around the outside, the address bar, the SSL lock icons, all of those things just work. So, for instance, if you're a web developer, you may have, well, if you're not in Pavel's talk right now, discussing all of the awesomeness about, or in the last session about the developer tools. The developer tools in Chrome are awesome. They're significantly better than, say, what you had in IE7 or IE6, which is to say very little. So you can use all these developer tools for Chrome Frame hosted pages while you're building apps for IE. So this is actually Chrome running under the covers here, whereas this is not. I don't get developer tools here. That's sort of sad. So that's pretty good. But it's one thing for small sites to be able to do this. It's another if large sites are adopting it and asking your users to go and install Chrome Frame. So I don't know if Ian talked at all about the new video codec that Google has open sourced in the last month or so, WebM, which is based on VP8 and the Matroska container format. But WebM is finally giving us a free, unencumbered, high-quality codec for audio and video. And YouTube is already supporting it. So the HTML5 beta for YouTube encodes a lot of video as WebM or H.264. And if you're using IE today, you can't view any of these videos, whether or not they're WebM or H.264. You're going to have to use the Flash. So how many of you are web developers? All right. So this is near and dear to your hearts, I'm guessing. So this is the acid test in IE8 getting 100 out of 100. It's not getting 100 out of 100 because IE8 suddenly got awesome. In fact, if we go and we load this page outside of Chrome Frame, yeah, okay. So this is IE8 showing on a test that exercises a lot of the more modern features that you would like to be able to take advantage of when you're building applications, but you just can't get to today. And in fact, the problem of getting to use those features isn't something that's just going to haunt you today as you start a new application. Until we can find a way to get new features to more users faster, this is going to continue to be a problem. Being able to use Canvas, which has been available in modern browsers for a couple of years now, would be great. But newer standards like HTML5 video, well, if that's on the same slow cycle for uptake as Canvas has been, relatively speaking, in the broad population, not necessarily in good browsers, but in terms of user browser adoption rates, then we're going to continue to face this challenge where the technologies that we can start to use from HTML5, from new, more modern standards, are significantly delayed from when they're introduced into browsers initially. We'd like to close that gap. So today, you're going to go target a new application for IE7 probably. If you're forward-looking, you may already be able to ignore IE6. Wouldn't that be great? IE7, I don't know if you've spent a lot of time with a feature set in IE7. It's a little better, but the JavaScript engine is an order of magnitude slower than Chrome's, or Safari's, or Opera's, or the next version of IE even. So we're talking about a huge differential in the sorts of applications that you can design and build today. And until we find a strategy for getting you off of it, getting your users to be able to take advantage of those features, we won't be able to get to this quickly. So Chrome Frame helps us get there. Hopefully in a transparent way. So there's a very long backlog of these features. Ian talked about some of them, and Brian Rakowski mentioned some of them earlier today. But the list is longer than I think either of them discussed. And I know that Ian is now giving a talk on some of the more detailed versions of some of these things. But any one of these could sort of revolutionize the way you build web applications. So for instance, Canvas audio and video give you the ability to build brand new kinds of applications without going to plugins. ARIA roles and states give you the ability to make applications accessible to people for whom they wouldn't be otherwise. The ability to GPU accelerate CSS transformations and animations is going to give you this really rich, responsive feeling for the kinds of applications today that are gated maybe by JavaScript performance or redraw and painting issues. You can do a lot more with the hardware that you've already got if you've got better software. I could keep going down the list. Things like App Cache are going to give you the ability to do offline applications, the ability to do drag and drop like Ian showed you. I mean, I want my pictures of cute kittens, but it's not going to happen as quickly as it would without drag and drop. So there's this very long list of features. We want to build applications that can take advantage of them, because if we don't have these features natively built into the browser, most of what we do today is to go try to find workarounds. So before I came to work at Google, I worked on a JavaScript toolkit called Dojo. And my job, effectively, was to go to try and find workarounds for you to use. So there are a lot of JavaScript libraries you can use, many of them very high quality. jQuery, Dojo, Prototype, Clojure, Gwt. A lot of these toolkits spend a lot of time trying to give you an even surface area to build on top of. But today, that means programming to the lowest common denominator. And the lowest common denominator is pretty low. Remember, that's probably IE6 or IE7 today. So we're talking about a JavaScript engine which is an order of magnitude slower, an inability to use modern vector graphics, no video and audio, the need to go to images for rounded corners, gradients, all the sorts of slick visual effects that you expect. You're paying a lot for, not just because you need to send more images over the wire for some of these effects, but also because you've got more JavaScript in the way. You can't just build and write what you mean in terms of HTML. You can't use new elements to go give you features like validation for forms, date pickers, a lot of the stuff that's coming in HTML5. So we spend a lot of time, money, and latency. Latency is really important. So I work on the Chrome team, and we're obsessed with speed. We can't sort of spend a couple of email threads without talking about how we're going to make something faster. And so one of the things that's really jarring to us is how slow web applications are compared to how quickly they could run. And so one of the things that's most exciting about HTML5 from my perspective is the ability for you to build applications that are faster and more responsive, not by doing more work, but by doing less work, by using more of the features that are built into browsers and doing less of the sort of triangulation among the feature sets that are available in other places. So the question, of course, shows up. Chrome Frame looks pretty awesome. I can use all of these features in IE. That's great. But why wouldn't I just ask my users to install Chrome? So it turns out that the problem of getting users to adopt browsers is as much a technical problem as it is an economic problem. Users, in many cases, as you saw this morning, some users don't know what browsers are. Some users do know what browsers are, but they don't have a strong incentive to move. So it's a little bit chicken and egg, right? If I build an application that supports IE7 and it works really well there, what incentive do I as a user have to move? Now, on the other hand, if I'm building an application and I don't support users of IE7 or IE6, that's a large population that I'm just leaving on the table for one of my competitors to come and build an application for, right? I mean, I'm by default turning off a very large percentage of the funnel into my potential revenue stream or my user base or the people who I'd love to make delightfully happy. So ignoring those users is a difficult judgment call for any web application developer to make. And for users, upgrading your browser depends on the applications that you want to use telling you that you need to go do something different than you're doing today. So we have a chicken and egg problem. We need a way to break the logjam. Users aren't necessarily going to all go get new browsers all at once, but we need them to get better browsers that auto-upgrade. So we need them to adopt more modern rendering engines, whether or not they necessarily choose to change their habits, whether or not they click on the big blue E to get to the internet, or whether or not they click on the Chrome icon. We want them to get new features faster so that we can start to use them, so that we can build applications that eventually say, it'd be great if you got a better browser. So lots of organizations find themselves mediating for users for exactly this set of concerns. So if I'm a large IT organization, say, at a big company, or a government, or a university, it's difficult for me to support, manage, and upgrade all of the browsers in my organization, partially because I'm responsible not only for the browsers, but also for the applications. My favorite example is a bank. You can imagine a small bank, doesn't have a large IT support staff. They've bought some application a couple of years ago that only works in IE. And maybe the vendor went broke. Maybe the vendor for the person that they bought the application from no longer builds or supports new versions of that app. In many ways, they'd be out of luck today. Many of the applications that they'd like to buy require new features. So many of the applications that you'd like to build would love to take advantage of those new features. Today, they're at an impasse. If I'm a salesperson for an organization that's trying to sell a new application into this company, it's difficult. I can say, we require this browser, and they're going to go, I'm sorry, I'm going to go with this other vendor. So you're at a disadvantage until you can give them an answer. So Chrome Frame is a way for you to give them an answer. And then we'll talk about how we're going to make this easy for organizations in the future. But generally speaking, if your users can't move because they can't upgrade, Chrome Frame gives you a coexistence strategy. So the coexistence strategy is probably the most crucial feature in Chrome Frame. Users have to have it installed in order for it to work, which is to say, if you serve an HTML page to a user with IE, and they don't have Chrome Frame installed, it just renders the way it always would. It just renders inside of IE's Trident rendering engine. If they do have it installed and the page sends the HTTP header or meta tag, then it switches into the Chrome Frame mode, but not until you add the tag to your site. That means that your applications have to opt in as well. So users aren't going to get blanket rendering for things which might not know about Chrome Frame and might break in other ways. And you get the choice to decide to support Chrome Frame in your applications. Your application is never going to be ambushed by a copy of Chrome that's masquerading with an IE user agent. You're going to have to know that you want to support this. So how do you opt in? It sounds good, but how do I actually use it? So it's simply an HTTP header. In fact, this is a header that Microsoft introduced in IE8 to control switching between different rendering modes of the internal rendering engine in IE. There are, if you look on MSDN, for the X28 compatible flag, there are other values for this. So IE equals 8 or edge or something like that. But if you specify Chrome equals 1, that's just a Boolean flag for yes, then Chrome Frame observes that this is a page that's intended for us if it's installed and is operating. And we flip into this mode. We start the Chrome rendering engine and pipe the contents down into Chrome. So the other way to do this is with the meta tag version. So the meta tag version of this is semantically exactly the same. You specify the same thing, and the same thing is available in IE. So you can use either version in IE to specify how you'd like IE to control its rendering, and you can specify either version for Chrome Frame. So why would I do one or the other? If I use the HTTP header, it's easy to roll this out across an entire site. That's usually how you do it. So if I'm, for instance, a large provider of blogs, say Blogger or WordPress. In fact, WordPress did this a couple weeks ago. WordPress, in a single HTTP configuration, a couple of lines, were able to turn on Chrome Frame's meta HTTP header for every blog they host. That is to say, TechCrunch, CNN blogs, pretty much everybody hosted on WordPress.com today is now sending this header, and they were able to do it with minimal work. At the same time, you can't simply add something to your document. You have to go change your HTTP server or change something in your PHP or your Ruby or your Java to go send a new header. It's not as easy to get started with. And in some large configurations on some large sites, you may not have the permissions to go change headers. You may not have access to your htaccess file. You may not be able to run code. So the meta tag method to the rescue. The meta tag method is ever so slightly slower. You won't notice. But it's easiest to get started with. It has a couple of drawbacks, though. The first is that it has to be in the first 1K of the document. It has to be smack dab at the top of the page. You can't have it sitting down towards the bottom of the page. We're just going to miss it. We're only looking, because we have to make this decision very early when the page is being served. We want to know as soon as possible whether or not we should switch into Chrome Frame mode. So using this in some templating engines in some large systems, it's difficult to maybe make a site-wide configuration change that requires adding something to all of the content in the entire site. In which case, the HTTP header version is an easy way to do it. It's worth noting that you can use them together. You can use them in conjunction. The first one that the browser sees will win. Okay. So what if Chrome Frame isn't installed? We've covered this a little bit. Basically, it falls back to the default rendering. Well, what if I want to force users to either get a better browser or to require Chrome Frame? So we've made that easy too. On the Google Ajax API's content distribution network, we're hosting a small script that we call cfinstall.js, and it provides a prompt. So I'm going to go disable Chrome Frame, and I'm going to come back to these slides. So Chrome Frame is implemented as an add-on to Internet Explorer. So I'm just going to come in here, and disable that. I'm going to restart IE. Close all the tabs. So if the user doesn't have Chrome Frame installed, and you include this cfinstall.js file in your document, users will get a prompt if you configure it to do this. And this prompt is actually just a copy of the install page in an iframe. So the install page here is google.com/chromeframe. So this is the exact same install flow. But notably, when users go through this install flow, through this iframed version of it, they don't have to restart their browser for this to work. So I just disabled the plugin. I didn't uninstall it and reinstall it. But I'll just go in and reinstall and restart the browser. But normally, when users hit this prompt, they install through this flow. They don't have to restart their browsers. Chrome Frame is available on the very next page view. So Chrome Frame is a very lightweight way to get your users into a better experience without requiring a lot of work on their part. The download is relatively small. The install is pretty quick. So let me quickly show you the code that makes this work. So this is the IE. As you can see, these slides are just HTML. But what we've got here at the bottom of the document, can you read this? Is that big enough? Maybe? Yes? No? Yeah, okay. So there's a conditional comment here. So this is an IE specific comment which says, which allows you to target particular things inside that comment block for different browsers. So in this case, this document isn't going to go request this script or run this code until such time as it's being loaded in Internet Explorer, which means you're not paying the cost for downloading the script and not running the code unnecessarily in browsers that don't require it. So we have one line that's the conditional comment, and then we just go grab a minified version of cfinstall from the edge cached content distribution network that Google runs. And then we have one more line here, which includes the line, it's another script block just directly after it, which says cfinstall.check. And cfinstall.check is a method which takes some configuration parameters, which you can sort of enumerate in the documentation. But in this case, I want it to overlay. So there's other ways. You can plug into this. You can change how you prompt your users if you want. You can do other kinds of prompting, and we'll talk about that in a little bit. But I'm going to say, I just would like you to overlay over the entire document the prompt to have users install Chrome Frame if they don't already have it. There's a close button which dismisses it for them. And so this is all the work that you'd have to do if you really do require new features that users might not have if they're running in Internet Explorer. Is that cool? Easy enough? All right. So we've worked really hard with Chrome Frame to make this as easy to adopt as possible. Remember, it's one line in a header or the top of your document, and it's a couple of lines at the bottom of your document to prompt users to install Chrome Frame if they don't already have it. And the prompt is optional. You don't have to do this. You don't have to use this for Chrome Frame. So for instance, WordPress.com or YouTube are doing this in an opportunistic way. So if the user has Chrome Frame, it flips into that mode. If they don't have it, they're not hassled. You can choose. If you require it, then you require it. If you don't, okay. All right, I'm going to come back in here and I'm going to enable Chrome Frame. And then I'm just going to restart IE because I didn't uninstall, I just enabled and disabled. All right. That we just covered how you would detect and prompt your users to install Chrome Frame on the client side. So what if you want to do this on the server side? For instance, Google Wave does this. And for Google Wave, you can tell your users, or Google Wave tells users, if you don't have a good enough browser, please go get one or install Chrome Frame. So how they do that, they detect the Internet Explorer user agent string, And they let users through who have this extension, the Chrome frame / version number extension on their user agent string. When Chrome frame is installed and it's active, it's always adding this to every request that goes out. So if you're detecting your user agent on the server side, you can look for this and know that Chrome frame is both installed and activated. So you can then maybe send the user agent XUA compatible header or let your users through and not prompt them. Make sense? The other important note here, the caveat, is that if you're detecting the user agent in script from inside of the content document, we report the user agent from Chrome to navigator.useragent. We don't report this augmented version of the Internet Explorer user agent because that would confuse a lot of existing scripts. For instance, Dojo or jQuery wouldn't understand this augmented user agent. And we want to make sure that your existing code will work as easily as possible with it. So note that there's a difference between what you'll be seeing on the wire and what you'll be seeing from inside scripts when Chrome frame is running. Make sense? Okay. So a key design decision in Chrome frame is to allow things to work as you'd expect them to, hopefully at every point. One of the important parts of this is that we use the network layer from Internet Explorer directly. That means that when you clear the cache in Internet Explorer, the cache from Chrome frame is cleared as well. When you clear the cookies, they're cleared as well too. The SSL system is exactly the same. We don't use Chrome's version of these low-level pieces of infrastructure because we want to make sure that if I log in, for instance, and I'm assigned a cookie on the Internet Explorer side, and then I go to a page that requires Chrome frame, you'll see the exact same coherent session in both places. We're working really hard to make sure that when you script cookies or when you use them from the network side, everything looks and acts the way it should, and that your privacy is respected. So for instance, if I use IE8s in private mode and I go to a new web page, what I'll see is a Chrome frame page, and that page opts into Chrome frame. What I'll see is a Chrome frame rendered page that's being rendered on top of not the normal profile that might save your sensitive data to disk, but instead Chrome's incognito profile mode, which prevents that from ever going to disk. So we work hard to make sure that your privacy is protected and that your intent is protected at every point in the user experience. Things should just work the way you expect them to inside of Chrome frame. So how does all of this work? So Chrome frame is a very small, I'll go back to that slide in a second, but Chrome frame is a very small component that loads inside of Internet Explorer when it first loads up. There's this thing called a browser helper object, and Chrome frame is implemented as a browser helper object. So Chrome frame loads when Internet Explorer loads, and then we start observing the content that comes across the wire. And then we make that determination when we see a page that's a top-level page and say, aha, that's for us, we'll go into Chrome frame mode. Or it's not for us, therefore we'll just fall through to IE's regular rendering. Remember that as part of this process, when a request is issued outbound, we always add this Chrome / version number to the user agent so that you can detect on the server side whether or not it's for you. So a request goes out, we add the user agent, and when the request comes back, we observe the content to make sure that we're always catching requests that are destined for Chrome frame and flipping into that mode. So remember I said that this is a very small component, this browser helper object? Well, that browser helper object doesn't actually do the rendering. That's just a part that lives inside of Internet Explorer. When we detect a page that's destined for Chrome frame, what we do is launch Chrome in an active document, which is a way that Microsoft provides for hosting other kinds of content inside of the same shell for Internet Explorer. So for instance, if you've got the Acrobat Reader installed and you view a PDF in IE, normally you won't be pulled into the PDF application or it won't download to disk. You'll see the PDF rendered directly in line in that PDF viewer. Chrome frame operates through the exact same infrastructure. We just render in line, but we render HTML and not some other proprietary language. So we do that by launching the Chrome browser process, which is this controller process, which provides the ability to render many tabs potentially. And in fact, if you've got multiple tabs in IE and they're all using Chrome frame, we won't launch the browser process multiple times. We'll just launch a new tab behind the scenes. It doesn't have the visible tab UI, but it is a new tab. So we launch the multi-process architecture, and then we launch a renderer process, and we plumb the content that we've been buffering inside of inside of Internet Explorer down to the renderer, and it all works. So you're getting the advantages of Chrome's sandbox, speed, and security features in terms of the browser process watching for malware, for phishing attempts, all that sort of thing. That's all active inside of Chrome Frame. We're not simply rendering things in WebKit. We're taking advantage of all of the safety and security features that are available in Chrome. So, the BHO, again, is tiny. It shouldn't change how IE loads at all. It's very fast. Unfortunately, because it is a browser helper object, we do require administrator privileges to install. And I'll talk in a little bit about how we're making that easier. But Chrome.exe starts on demand. And we render things with the sandbox multi-process browser model. So we support Internet Explorer 6, 7, and 8. We support Windows XP Service Pack 2 and above. Service Pack 1 and below don't have some of the necessary security features to make Chrome's sandboxing system, which is very unique and incredibly secure, work. So we require at least Service Pack 2 for Windows XP. And we do require administrator privileges to install. The browser helper object system that Microsoft provides to extensions requires that you write to a portion of the registry that normal users don't have access to. So I mentioned that we're going to make it easy for site administrators to go and install Chrome Frame. So there's a system called MSI, which is sort of the regular packaging system for installers for Microsoft operating systems. And so we're going to be making an MSI and a series of group policy templates available for administrators to push Chrome Frame out across their entire enterprise in the near future. We've just entered the beta for Chrome Frame, and the MSI is sort of the next big to-do on our list. So I'm going to skip over this very briefly. For those of you who are C++ hackers, yes? Okay. For you, sir, Chrome Frame is embeddable. If you want to use Chrome Frame in a big C++ application and you want to render some HTML and you want that HTML to be awesome and not slow, you can use Chrome Frame. All right, enough about that. So we're sort of obsessed with speed on the Chrome team, and a lot of the features in Chrome help you out. Like I said earlier, we use IE's network stack, so that has some limitations. But we get a lot of benefits for free because we're using Chrome. So DNS prefetching, parallel script execution and fetching, V8 and the WebKit engine, all those things are available to your pages that make things go a lot faster than they might otherwise. At the same time, it's a plugin. So you know how I mentioned earlier that we don't launch Chrome when you first launch the browser. We don't want to slow the browser process loading. It can potentially take a little bit of time for Chrome and Chrome Frame then to start up the browser process. So for your applications, you should test. You should find out. I should note here that I've spent the last month making Chrome and Chrome Frame startup go significantly faster. So the performance that you see today in the beta and developer channels is not the performance you should expect for startup in the near future. Check back in about a month. Things are going to get really fast. That is to say, that's the cold startup performance. Warm startup, you shouldn't notice transitions between pages. So today we're in beta. We just launched the beta a couple of weeks ago, and we're very excited about it. That means that we think it's ready for sort of broader use. So YouTube is using it. Orkut just started using it across the board for IE6 users. They no longer allow IE6 users to natively visit Orkut. You have to go and install Chrome Frame or get a different browser. So we're starting to see some large sites pick up Chrome Frame. In addition to that work, we're also continuing to make sure that the things, the menus, the user experience that you expect from Internet Explorer, both in terms of safety and security, but also in terms of the menu systems and all of the UI, just works in Chrome Frame. So there's a series of issues that we're continuing to work through, but once those are resolved, we expect to be in what we call the stable channel for Chrome relatively soon. So Chrome Frame is part of the Google Chrome project. So again, it's an open source project and you can get involved. We have one C++ hacker here, so he can come join us if he wants. You, who are maybe not a C++ hacker, can start to use Chrome Frame on your sites, start to ask your users to install it, and please get involved in the mailing lists. We'd love to know how it's working for you, how we can make it better, and how we can help deliver HTML5 to your users significantly faster. So if you've got questions, if you feel like this is a useful tool, we'd love to hear from you, and all of the team is on the mailing list, so if you send us a question, you'll be talking to all of us. All right, questions? I know I'm between you and lunch, so. No questions? None. All right.
Hi. So first of all, it looks amazing, in my opinion. The only problem I see is the installation screen for those users that don't have Chrome frame. So you mentioned like in a sentence that you can customize it. The question is to what extent, because obviously if I go to read some blog and suddenly I get some sort of weird installation window and I'm a dumb user, I'll probably close it, I'll never come back again. So how can I integrate the Google Chrome frame installation into my site?
Good question. So that CF install script, it's just a baseline. You can choose to, obviously, we are going to have to require users to click through the end user license agreement in order to get Chrome frame. So if I go to, let me see, if I go to that install page again, google.com/Chrome frame. The important part of this installation flow is that when they click on this, they get presented with these terms of service. They're going to have to agree to this. The rest of the installation flow, it's not just a download that you install. Chrome frame auto updates like Chrome does. So we want to make sure that once we fix this problem for you right now, that users are getting the fix from now on. Right? It'd be one thing if we were to give them a better rendering engine at some point in time. It would be significantly better if we could give them a rendering engine that was going to continue to get better over time. So we get Omaha, the Google auto update system, as part of this, and Chrome's auto update system. So we need them to agree to this. So if you redirect them here to this page, however you do it, however you choose to do it, that should be enough. I can talk to you about how this works, but generally speaking, the CF install script, again, Chrome frame is a plugin, so there's an ActiveX control. We watch for it on the background, which is how we know that once it's installed. And you can do the same thing in your script, or you can take the CF install code and go just hack it up and do it however you want. As long as that part works for you, the install flow should be relatively painless, and you can prompt them however you want. For instance, Wave is doing a custom install prompt like this.
Yeah, thanks.
Yeah. Any other questions? All right, thank you so much. And again, I'll be happy to take your questions in the hall.